Bionox is motivating wellness. Part from your book as well, where you looked at vegetation in different parts of the world. So does the celery grown on the West Coast say have the same value as the celery grown on the East Coast as far as nitrates are concerned?
Jay, we had this grand idea that we could change policy and change dietary guidelines and make good recommendations. And in order to make that argument, we had to figure out how much celery would one need to eat to get 300 milligrams of nitrate, or how many beets, or how much spinach or lettuce. So we went to, this was a study in collaboration with Texas A&M University in food science. So we went to New York, Raleigh, Chicago, Dallas, and Los Angeles, really all four corners of the U.S. And we went to the same retail grocer, bought the same vegetables off the shelf, both organic and conventionally grown vegetables, and then just analyzed it for nitrate and nitrite. And you solved the riddle here, but the point is that celery in New York, you'd have to eat 60 stalks of celery to get 300 milligrams of nitrate, where if you live in Dallas or Los Angeles, you could eat about 8 or 9 stalks of celery and get enough nitrate to lower your blood pressure. So there's these regional differences. It's based on soil conditions, farming practices. But the thing that shocked me, Jay, was that organically grown vegetables have about 10 times less nitrate than conventionally grown. So, we live in this world where, you want to eat organic, eat clean. I think that's important that you're not being exposed to herbicides and pesticides. But the point is, you cannot eat enough organic celery, organic spinach, organic beets to get enough nitrate in your diet to normalize your blood pressure.
Yeah. So would you say then that supplementation with a standardized amount of nitrates in it would be more important now than ever because of that?
Look, I think it fits this whole paradigm of if you're in chronic disease is caused by two things. Your body's missing something that it needs, or it's exposed to something it doesn't need. So to address the first, and even the NHANES study, these national surveys of food, we know that 75% of Americans are deficient in magnesium.
Right.
And 95% of Americans are deficient in iodine. And you're not getting it from your diet, so what do you got to do? You have to supplement. And so the science is such now that we're at a time where it's clear that Americans are deficient in nitrate from their diet, and it's impossible to be able to estimate or guess if you're getting enough nitrate from your vegetables. I mean, because I have the analytical equipment, I can measure my own food, right? But most people can't. So what do? You supplement to standardize that, to give the body what it needs to do what it's designed to do. And I think that's a very rational approach.
Absolutely. Just to go through real quickly, I know you touched on it, but let's just go through the whole process very quick. You got your 300 to 400 milligrams of nitrates you're going to consume, whether it be supplement or combination of foods. You're consuming it. What happens next? How do we get from that to nitric oxide?
Yeah. So when we chew, you masticate, you chew it ideally for a long time to break it up into small particles. And during that, nitrate and nitrite are water soluble. So it becomes in solution, and then these bacteria then begin to work on this. And so the bacteria that we're interested in live in the kind of the dorsal part of the tongue, the back part of the tongue, in the crypts of the tongue. So when we eat these vegetables, it's swallowed, and then nitrate, it spends a little bit of time in the stomach for digestion, and then the stomach empties and goes into the duodenum, the proximal gut. And there's a protein there that binds nitrate from our diet, and then it concentrates it back into our salivary glands. This process takes about 80 to 90 minutes from the time that we eat to the time we can measure it in our salivary glands. So then this is a slow process. So every time we salivate, we're getting a burst of nitrate in the oral cavity. And then these nitrate-reducing bacteria slowly metabolize nitrate into nitrite. So we know that about 20% of the nitrate that's consumed is absorbed in the proximal gut.
Okay.
And then about 25% of that that's put back in our salivary glands is reduced to nitrite. So what that means is you basically have a 5% total reduction. So if you're consuming 300 milligrams of nitrate, 5% of that are you get 15 milligrams of inorganic nitrite from that burst. So then we have nitrite-enriched saliva, which is what we're measuring with the test strips. And then when we swallow our own saliva, and this happens for the next several hours after a meal, we're getting a burst of nitric oxide in the acid environment. So nitrite becomes protonated when it hits the stomach, and you generate nitric oxide gas. And this is biologically active because it's been shown to the nitric oxide that's produced from swallowing your saliva can kill things like H. pylori, these ulcer-causing bacteria. It can kill E. coli. So if you eat some salad with some E. coli on it, if you make stomach acid and nitric oxide, then you won't get sick from that. But it also helps in the absorption of nutrients, things like iron and B vitamins. So it enhances gastric mucosal blood flow so you can absorb these nutrients. And it prevents the ulcerations from NSAID use. So this pathway is critically important and fundamental for everything we do about digestion and nutrient absorption. But if you can't make stomach acid, you can't make nitric oxide. If you use an antiseptic mouthwash, make nitric oxide. And these are, I think, very important things that most humans have good intentions on what they do every day, right? Because what they think there's some collateral damage. And, you know, I tell people if you want to enhance nitric oxide or optimize nitric oxide, you have to do two things. Stop doing the things that are disrupting the body's production of it, i.e. mouthwash, proton pump inhibitors, and start doing the things that are clinically and scientifically proven to restore it. Change your diet, supplement when you need to, get moderate physical exercise, sweat, sit in infrared sauna. All these things are scientifically proven to improve your nitric oxide production.
Very good. And what's the role of vitamin C in all this? I know it plays a factor as well.
Vitamin C is critically important because it keeps this pool of BH4 tetrahydrobiopterin in a reduced state. There's a certain electrical potential you need to do that. But I think really the fundamental role of vitamin C and the things that we do in enhancing nitric oxide production is that when NO is produced, again, it has a half-life of about 2 milliseconds. So it's biologically active, but what happens is NO binds to other molecules, things like glutathione. It's oxidized into inorganic nitrite. And then that's what's transported along the vascular tree. And so we can extend the biological half-life of nitric oxide from 2 milliseconds out to tens of minutes or hours because we understand how it binds to proteins or even small peptides like glutathione. And then vitamin C, as it's traveling down the vascular tree and goes through the arterial venous transit, the oxygen tension changes. And so vitamin C helps to release that nitric oxide from the cysteine bond and basically release bioactive nitric oxide.
Very cool. Awesome. Okay, I think you covered a lot about what inhibits nitrates from converting into NO. All those, the mouthwash and the, of course, long-term antibiotics and proton pump inhibitors, TUMs, those type of things definitely are a problem. So let's just reiterate now. We've talked a lot about nitric oxide. I think what it's important is that people really want to know what the end goal is. Okay, that's great to produce nitric oxide. What's it going to do for me?
Yeah, that's right. That's a good point because I guess 10 or 12 years ago, we were trying to go out and educate the masses, both physicians and consumers, on the importance of nitric oxide. And no one knew what it was. Today, we've done a little bit better job. But here's what we've learned is that people really aren't that interested in what nitric oxide is. They're interested in what nitric oxide does.
Absolutely.
So what does it do? Well, it normalizes your blood pressure. It suppresses inflammation. It improves exercise performance. Basically, anything you want to do in the human body is determined by its ability to make nitric oxide. So for instance, in exercise performance, if you want to perform like an elite athlete, then you've got to enhance your mitochondrial efficiency. You've got to maximize oxygen utilization and get nutrients and oxygens to every cell of the body. So how do you do that? You do that through nitric oxide production, which then dilates the blood vessels. You get oxygen and nutrients to individual cells. But nitric oxide also enhances mitochondrial biogenesis. So you have more mitochondria generating more ATP or cellular energy with less oxygen. So you become a very efficient machine. And to the contrary, if you don't make nitric oxide, you have less mitochondria. They're not efficient at converting, not generating ATP, and you become exercise intolerant, And if for instance, if you're trying to remember where you left your keys, you have to increase blood flow to certain regions of the brain to recall memory. And how do you do that? You generate nitric oxide, you open up those cerebral blood vessels, and you remember where you left your keys. If you can't make nitric oxide, you get vascular dementia. If not corrected, you develop dementia and Alzheimer's. If you want to increase blood flow to the pelvic region for sex, you have to dilate those blood vessels to get blood flow and engorgement. If you can't make nitric oxide, you don't increase blood flow, you don't get an erection, you have sexual dysfunction. So it's all about performance. And people can define performance as they will, but if you want to perform in the bedroom or on the athletic field or in the boardroom, you have to have nitric oxide.
Well, sign me up for that. I'm on board. So yeah, very, very important. And again, we're motivating wellness. People are nitric oxide deficient. You're gonna feel it. It's gonna show itself in so many different ways. You increase it, as you mentioned, you think better, your mood's better, your immune system's better, everything's better. So that's one thing.
That's what's exciting about this field, Jay, is that it's not, people take things like vitamin C or vitamin E or fish oils on blind faith, right? I mean, I take them, but I don't feel any different.
Right.
I mean, critically deficient, you're not going to notice it. The things with nitric oxide, if you push yourself and you go and you have like for me, I have a normal exercise routine that I do every day when I go to the gym. And if for some reason I don't have nitric oxide on board, that same exercise routine, I struggle to get through it. But if you take it, you know that you can feel your body performing better. The perceived exertion is better. And you can just go longer, faster, stronger, and you can feel it.
Yeah, that's certainly what I loved about it too. There's no doubt people, this is type of nutrition supplementation where you're not going to wonder if it's working. You feel the results. So let's see. So let's just talk about this again. You can maybe tie in the concerns that people have about nitrates in general. People have heard bad things about nitrates and nitrites that are used in the preservation of cured meats.
Yeah.
Right.
Yeah.
And so maybe you could talk to us about the difference between, let's say, the nitrates that are in beets as compared to nitrates that are in cured meats, and then also that whole idea of these things causing cancer.
Yeah. Well, Jay, this may be surprising to you and your listeners, but we've been misinformed by the media and the government.
Happens. Fake news.
Yes, for the past 50 years or longer. And I think, again, I think people have good intentions when they do nutritional research or epidemiology, but you have to recognize too, people have an agenda. So what I don't argue with, if you take nutritional epidemiology as a branch of science, and so the point of that is to figure out what is the nutrient in certain food or dietary patterns that confer a certain outcome. So for instance, Mediterranean diet protects the patients from a heart attack and stroke and protects the cardiovascular system, reduces incidence of cancer. What is it about that? We don't know. To the contrary, there's some increased risk of people who eat cured and processed meats. For example, the highest quartile of people that eat cured and processed meat have a certain increased risk of developing stomach cancer or colon cancer or different types. So back in, I guess, probably in the 50s, it was recognized that nitrite cured fish in these contrived systems would generate an N-nitrosamine. And then nitrosamines are mutagenic, carcinogenic, and can cause cancer. So then that was the first link between consumptions of cured and nitrite cured meats and the formation of nitrosamines, which then provided a biologically plausible mechanism for this increased risk of cancers. So epidemiology is designed to demonstrate an association. You do this, you get this, but it's never designed or intended to reveal causation. So that's where we start, and then we have to work backwards and figure out what's the mechanism of action or what's the biologically plausible mechanism. So that was when it was recognized that nitrite can form nitrosamines, and nitrosamines can cause cancer. That's the link. But in 1970s, it was recognized that vitamin C completely inhibits this nitrosative chemistry. So I think back in the 1970s, the Code of Federal Regulation changed that any food to which you added nitrite as a curing agent, you had to add a certain stoichiometric amount of ascorbic acid. In the food industry, they use erythrobate, but it's basically, it does the same exact thing. So you basically inhibit any nitrosative chemistry. And then you fast forward, probably 20 years to the early 2000s, it was recognized that the 80% of our nitrate and nitrite comes from consuming green leafy vegetables and not cured and processed meats. In fact, we published on this, I think, in 2012 or 2013, that 80% of your nitrite and nitrate comes from green leafy vegetables, about 15% comes from endogenous NO production, and about 5% comes from swallowing your own saliva. So if this were true, if nitrite cured meats and nitrate cured meats cause cancer, vegetarians or people who eat a plant-based diet would have about a 10 times higher rate of cancer, incidence of cancer, than those who eat cured and processed meat. And we know it's just the opposite. A vegetarian diet, a plant-based diet actually inhibits or prevents cancer formation. Now you figure out, okay, what is the mechanism? And we know through a number of different mechanisms, whether it's P53 activity or enhancing mitochondrial function, preventing the aerobic fermentation that occurs in cancer. Nitric oxide is responsible for that. How do you get nitric oxide? It's from nitrite and nitrate. And there's so little residual nitrite and nitrate in cured and processed meats that you can never consume enough to get 300 milligrams. I mean, it's impossible. So we basically turned this around completely. And, Walt Willett, who's probably the preeminent nutritional epidemiologist at Harvard, wrote that section of my textbook, Nitrite, Nitrate, and Human Health and Disease, years ago. And he basically admitted, look, what I don't discount is the nutritional epidemiology that say, if you do this, you get this. So there is an increased risk of certain cancers from cured and processed meats. It's hard to, iron out because there's so many confounding factors. People who eat cured and processed meat tend to smoke more. They tend to drink more. They have certain lifestyle things. But what's clear is that nitrite and nitrate are not responsible for the increased risk of cancers in people who eat cured and processed meats.
Got it. Yeah, I appreciate that.
But to get to your point, let me just make because you asked a very important question. What's the difference? There is no difference. The nitrate that's found naturally in vegetables is the same exact nitrate that's found in cured and processed meats. In fact, now they've got these curing methods where they're adding celery salt to the cured meats. So it's a natural source of curing, but you're basically getting the same thing as adding sodium nitrite or potassium nitrate to the meat product. You're just doing it through.
Yeah, makes sense. It's identified by the body in the same way.
That's exactly right.
Right.
Join Dr. J next time in episode 3 with Dr. Nathan Bryan.